Hello, we are Team Chaos, a team from Chess Academy consisting of me, Theo, Anton, Vincent, Victoria and Mika. Together with Grafana's new AI assistant, we have created a Grafana dashboard that show and track carbon dioxide emissions and electricity costs for servers that companies are hosting through a cloud service provider like AWS or Azure. The core goal for most companies is to reduce costs, but lowering the company's carbon footprint is quickly climbing the priority list. What we found is that companies might not be fully aware of where their servers are being hosted, which can lead to unnecessary costs and untracked emissions. Generally, decisions are based on server performance and cost efficiency, while often ignoring sustainability. And that's where our solution Carbon Shift Dashboard comes in. It helps companies identify which regions are cheaper and more emission efficient with your current cloud service provider. With Carbon Shift, companies can save money, boost performance, and shrink their carbon footprint at the same time. And now Anton will show you a demo of the Carbon Shift dashboard.
Thank you, Theo. Let me start by demonstrating in real-time monitoring. I'm going to connect to one of our EC2 computer workers in AWS and running a CPU stress test. This will simulate high workload and will watch the carbon emission change in real time throughout the demo. Here you can see the entire dashboard. This has been created both manually and with the help of the built-in Grafana assistant. Left panel, the first panel shows the pricing per hour for our EC2 instance right now at AWS. Sweden is the most expensive while the rest of the countries are pretty much the same. But price isn't the whole story. If we look to the right, it's where it gets interesting. This shows grams of CO2 emitted per dollar spent. Even though Sweden is the most expensive region to host in right now, because of the extremely clean electricity production, it still provides the lowest CO2 per dollar spent. Still, if costs are the priority, a company can choose France that has still the best balance between cost and emission. Going down a bit, you see our what-if analysis. We are actually running our instances in Sweden. But this shows our CO2 emissions. What if we ran the exact same workload in other regions? Right now, we're at about 0.52 grams per hour in Sweden. If we move to Germany, if we moved our service to Germany, we would emit over 9 grams. This is nearly 18 times more CO2 for the same workload. If we go down a bit, this panel shows live carbon intensity from electrical grids across Europe over the last 24 hours. The data comes from real-time grid APIs. You can see Sweden consistently stays below 30 grams of CO2 per kilowatt hour, while Germany spikes up above 400 during peak hours. This volatility is due to Germany's reliance on fossil fuels, while Sweden uses mostly hydroelectric and nuclear. Next is our carbon AI assistant. We use Amazon Bedrock with Claude 3 to analyze our infrastructure and provide intelligent recommendation. The AI looks at our current emissions, compare regional options, and suggests optimizations. This integrates seamlessly with Grafana Assistant. We can ask questions about our carbon footprint and get AI-powered answers in real time. The AI has access to our metrics via Flask API that queries Prometheus and calls Bedrock. Remember that the stress test we started? Let's see the impact. This graph shows CPU uses per instance, and you can see how our computer workers spike in it to nearly 100% during our stress test. This directly impacts carbon emissions. High CPU usage means more power consumption, which means more CO2 emissions. The AI can detect these patterns and suggest right-sizing instances and using auto-scaling to reduce waste during idle periods. So in summary, Carbon Shift gives you real-time visibility into your cloud carbon footprint with AI-powered insights. We're using real grid data from an API, monitoring with Prometheus and Grafana Cloud, and leveraging Amazon Bedrock for intelligent recommendation. This isn't just about emission, it's about making smarter infrastructure decisions. Because the cheapest region isn't always the cleanest. And with the right visibility, we can make better decisions for both our budget and the planet. Thank you.
Even though we have managed to implement a lot of features, we came up with some ideas for future development that we did not have time to implement today. What could be done is deploy an AI model to Grafana panel that automatically gives a report with feedback and insights based on the data from the dashboard. Additionally, it would be cool to implement a company carbon budget and alerting system that tracks the company's total carbon emissions and shows a burn down chart against their carbon budget. Grafana could then automatically alert the user if they're nearing their carbon budget. It's been a great experience learning Grafana and all that comes with it. We have realized it's a very powerful tool full of possibilities if used right. None of us in the group have used Grafana before, and the learning curve was pretty steep, but the AI assistance has proved to be very useful to quickly get dashboards and panels up and running. So, from us, thank you very much for listening.